Hello, my name is Esteban Sanchez, and this is a demonstration on software cost estimation for Do178 projects. I'm going to start sharing my screen to demonstrate the concepts. I always like to start my demonstrations with a view of what the end product looks like. And here is an estimate in SEER. This is an estimate for flight software. It includes it's an estimate for an entire aircraft. This is all the software that goes into an aircraft. It includes, as you can see, word breakdown structure. This is where we decompose the software into the different components or modules of the solution. And in particular, this estimate right here includes autopilot, navigation, vehicle monitoring, system monitoring, recording, transverse functionalities, input-output management, displayed, a human-machine interface, and some firmware or platform software. So the word breakdown structure is basically where we create, or actually where we decompose the software that we're trying to estimate into smaller components. If I expand one of these components, I can see some elements underneath. So I can see, for example, that on the autopilot, we have some this design assurance level A. This is Do178 level A, mission critical software. And this is design assurance level C, all right? So these two elements, each one has its own set of parameters and characteristics. And for example, DAL-A code is estimated with higher testing, higher levels of quality assurance, structural coverage, robustness testing, formal documentation, problem reports, and all the requirements of Do178 DAL-A. And then DAL-C is estimated with different assumptions, okay? Assumptions that are specific of Do178 Design Assurance Level C, okay? I will be explaining how to do an estimate, so how we get to this point, okay? Right now, I'm giving you an introduction to the end product, okay? So we have the word breakdown structure on the upper left. On the upper right area, this is where we have the parameters, okay? So SEER is a parametric estimation tool, and this implies that there's an underlying set of parameters that are used to describe these elements here. Parameters include, for example, lines of code, reuse assumptions, function points, experience and capabilities, characteristics of the development environment, such as automation tools, maturity of the practices, characteristics of the product. For example, what's the stability of the requirements? What is the level of documentation or specification that needs to be produced? Level of testing, level of quality assurance, level of rehost from development to target. So I will be explaining some of these parameters. At the moment, I'm only introducing this, okay? So this upper right area, this is where the parameters are, okay? And then on the lower side of the screen, right here, we have the results. We have the estimates, and basically the estimates are reported by SEER using charts and reports, okay? So SEER has different charts and reports to show the estimate results. For example, the quick estimate report gives us the overall picture. It tells us, for example, what's the overall duration, in this case, 35 months, almost 3 years. what's the total effort months, total effort, development effort hours, okay? Development cost, and then productivity as well, hours per line of code, total lines, and defects, okay? It would also show us maintenance figures if we were estimating maintenance. This particular estimate that I am showing right now, it doesn't have any maintenance, but SEER can also estimate maintenance, okay? I want to make that very clear since the beginning. SEER for software is a tool that can estimate maintenance. I'm sorry, it can estimate development, okay? That's the non-recurring aspect of a solution, meaning the development that includes requirements, design, coding, testing, and integration. And then once the software is flying and operating, SEER can also estimate the ongoing support or maintenance for the next, 5, 10, or 20 years, as long as you need. Okay, it's just that this estimate doesn't include any, it doesn't include any maintenance. All right. So different reports are available. For example, this is the quick estimate report. We can look at reports by fiscal year. If we want to get an idea of what's the cost per fiscal year, including inflation. If we want to break down the estimate by by the different activities and labor categories. All right. So SEER gives us that perspective as well. How many hours are invested into each of these phases. I will be explaining these phases in a minute and how they map to the Do178 life cycle. Okay, so these phases are very consistent with Do178. And that's because when SEER when SEER was born 40 years ago in the 80s, SEER was born in an aviation environment. So SEER was initially created to support Do178, especially for the Air Force. Okay, it was born kind of in a Do178 environment 40 or 30 something years ago. So it's not a surprise that a lot of the life cycle phases and a lot of the names and calibration and parameters are consistent with Do178. Okay, so hours by labor category, it's another report. We can see cost, in this case, cost by labor category. We can see an activity report in case we are more concerned with activities. So there's plenty of reports and charts that can be enabled. In fact, we have more reports. Okay, it's not my intention to show you all of these reports, but we have different reports. If you want to see the estimate by year, by month, if you want to see the inputs that are driving the estimate by labor category, by WBS. I love, for example, one of my favorite reports is hours by activity. Okay, this gives us, as you can see, a nice breakdown of all the modules, okay, in the work breakdown structure and the effort invested in each of the phases, okay, system requirements, software requirements, and so on. In addition to reports, the tool is also loaded with plenty of charts. Okay, we have different, for example, pie charts. In this case, to illustrate the allocation by activities. Okay, so how many hours or basically what percentage of the hours is being allocated to system requirements, software requirements, preliminary and detailed design, and so on. Okay. We could also look at allocation by labor category. Okay, if you want to see how much effort is being allocated to the analyst, designers, programmers, testers. As you can see, this is a Do178 project, so there's a significant amount of effort budget assigned to the testers. That's because They need to do all the reviews. They need to do all the requirements-based testing. They need to do structural coverage. They need to do SVCPs and SVR creation. So a lot of the hours goes into the testing. We could look at staffing. We could look at, for example, risk analysis charts. Okay, we can look at probabilistic distribution of the estimate, and many other things. Okay, so in essence, what I want to do, or what I'm trying to do right now, is give you just a quick overview of the user interface and what are the different things that you're seeing here on the screen. Again, this is an estimate that is already done. Okay, so I'm showing you this as the end result. As in summary, we have work breakdown structure, which is a hierarchical decomposition of the estimate. We have parameters here on the upper left. These parameters are driving the estimate. And then we have the outputs. And these outputs take the form of different reports and different charts. Okay? Now, before I show you how to generate an estimate, like what's the process that I follow to get to this point, let's talk about the activities, the scope. Okay, let's talk about the scope of the effort that is estimated by SEER and how that maps to Do178. Okay, so I have prepared this document. Okay, this document is a summary of all the artifacts that need to be produced in a Do178 project. Okay, so starting from the top, these are the Do178 phases. Okay, you are already familiar with this. If you work in Do178, you will recognize that there's a system requirements phase, there's a software requirements, preliminary. I'm sorry, no. These are not the Do178 phases. I'm sorry, these are the SEER phases. Yeah, these ones here in blue are SEER phases. Okay, and these SEER phases are mapped to Do178 processes and deliverables. For example, during the software requirements analysis phase that is estimated by SEER, SEER includes all the effort to develop and review and validate software requirements, including your SRD. Okay, SEER will also include the system requirements to high-level requirements traceability matrix. Okay, so this is the SRS to HLR trace matrix and reviews. Okay, so for example, if we go back to the SEER estimate, we're looking at, in this case, we have 900 hours associated with system requirements. These 900 hours are these are hours that the software team uses to validate system requirements, to review system requirements, to identify missing system requirements, conflicting system requirements, identification of derived requirements, feeding derived requirements back to the system safety analysis for approval and clarification. So in a Do178 environment, the system requirements are outside of the Do178 process. Do178 focuses on software development, and the system requirements are before the software development. There is a team of systems engineers that puts together the system requirements. So that effort, the system requirements, is not included in the SEER estimate. SEER has a phase called system requirements, but this is the software team supporting the creation and the review of the system requirements. Okay, 900 hours in this estimate. And then we transition into software requirements. Okay, for this estimate, SEER is estimating 2,642 hours. This is all the effort related to taking the system requirements and decomposing them into high-level requirements, creating an SRD, software requirements document, reviewing the SRD, approving the SRD, creating a traceability matrix between your HLRs and your SLRs, okay? Traceability matrix between high-level requirements and system-level requirements, okay? So these hours right here will cover these artifacts, okay? Notice something important in this diagram is everything that is in black is covered by the SEER estimate, okay? Things that are in red are not covered by the SEER estimate, at least not out of the box. We will have to do some calibration or add some additional effort to cover for the items in red, okay? The items in red are basically plans and standards, okay? SEER for software does not estimate any effort for your PSAC, SDP, SVP, SEMP, and SQAP, and also it does not include effort for your standards, okay? Typically, organizations have templates and genetic versions of plans and standards. So the effort associated with plans and standards is usually small, okay? With the exception of the PSAC, okay? The PSAC is usually the only document that is very project specific, okay? The plan for software aspects of certification PSAC is usually project specific. So this document usually requires some effort, but development plan, verification plan, configuration management plan, quality assurance plan, and all the standards, most of the times, organizations that are in Do178, they have generic versions of this that can be reused across projects. The other things that SEER does not include is, for example, parameter data item files. This is something new in Do178 DLC. Okay. There's a special calibration that can be used to include those. SEER does not include the data analysis and control flow analysis. Okay. And it does not include the software accomplishment summary, okay? You will have to add that manually. But as you can see, the majority of the artifacts are included, okay? DSRD, SDD, interface control drawings, traceability matrices, source code, low-level requirements, software verification cases and procedures, memory stack, timing analysis, structural coverage analysis, all the review records, configuration management records, quality assurance records, all of that is included in the SEER estimate, okay? So going back to the SEER estimate, we then get into preliminary and detailed design. In Do178, there's only one phase called design, and the end result of that phase is the software design document. SEER has two phases of design, okay? Preliminary and detailed design. Together, these two phases map to the design phase in Do178, okay? So the design phase, as you can see, includes the creation of your software design document, interface control drawings, specifications, low-level requirements to high-level requirements, traceability matrix, and review of the traceability matrix, okay? We then get into the coding and unit testing, okay? Of course, SEER includes a phase to estimate the programming effort and the creation of the source code and the executable object code. So during the coding phase, we have source code, we have code reviews, we have low-level requirements to source code, traceability matrix, and unit testing, okay? It's included in SEER, code reviews, and also initial draft of software verification cases and procedures, SVCPs, all right? After coding and unit testing, we get into component integration and testing. Component integration and testing, it can be understood also as part of coding, okay? Coding and unit testing is where you create the individual functions. So the individual C functions or C++ classes or functions that you create, that's coding. And then you need to integrate these functions. You need to have functions call other functions, pass parameters, arguments, data to other functions. So that's the component integration and testing, okay? So together, these two phases map to what we understand as coding in Do178, okay? Once we have source code and executable object code, okay? Once we have that, we need to start testing, okay? Testing is one of the most important parts of Do178, okay? So SEER includes, it includes three phases of testing, okay? During the component integration and testing, there is some lower level testing, like integration testing, unit testing. But then we also need to execute program testing, okay? Program testing is one of the most important testings in Do178. This is requirements-based testing. Okay, this is where you develop software verification cases and procedures, and then you execute the SVCPs to make sure that the executable object code satisfies the requirements. So basically, whatever requirements we wrote in the requirements phase, we implemented those as designed, and then eventually source code and executable object code. We then need to, basically, we need to verify that the executable object code meets the requirements, okay? So we have program testing and also system integration and testing, okay? Program testing is more like testing the software isolated, probably in a lab environment with stimulation, you know, maybe an in-circuit debugger or simulators. And then we have system integration and testing. This is more like higher level testing where we test in the real hardware or a prototype, maybe an evaluation or a prototype version of the hardware. So we also need to test that the software can be loaded into the microprocessor in the hardware and that the software satisfies the requirements, okay, executing on the real hardware. Okay, so these testing phases in in SEER map to the testing phases in SEER. Actually, Do178 call it verification and validation, V&V. These are all the artifacts that are produced in the integration and verification phases. We have test cases, robustness test cases, data and control flow analysis, structural coverage analysis, which is mandatory, memory, stack, and timing analysis, okay? Software verification results, and software configuration index. Okay, all of these artifacts that you see in black are estimated by SEER. In parallel with this life cycle, we have review records. So after we do a review, there's gonna be a reconciliation of the defects that were found, how those defects were fixed, the different resolutions. All of these are review records. We have configuration management records, such as configuration items, tools document, baselines, problem reports. All of this is estimated by SEER, okay? So that's kind of an overview of the activities that SEER estimates and how these activities map to the Do178 phases, okay? So as you can see, it's a very good match. It's not a coincidence that SEER is a very good match with Do178. It's because SEER was born in that environment, okay? So SEER is very strong when it comes to Do178, okay? Now, the other thing that I like to show you, once that we understand what an estimate looks like and the different screens, now I would like to show you how you do an estimate from scratch, okay? So let's start by creating or opening a new instance of SEER. Okay, let's now talk about generating estimates in SEER. Basically, what is the process that we need to follow to get to this point where we have an estimate? Okay, so let me try to explain that. So what you're seeing here is this is what you're going to see when you open SEER. Okay, so SEER will show you some options to create a new estimate, some options to open existing estimates, in case you need to do changes or follow-up work on estimates. And this is a list of the most recent estimates you've been working on. Okay, so for the purposes of this demonstration, I'm going to click on the New Estimate button. Okay. Let's imagine that we're estimating some flight system. It can be an autopilot, it can be a radar system, it can be a navigation system, it can be a, TCAS, notification, communication, control system. It can be anything. Let's just make it generic, okay? It's a flight system. So we start by assigning a description for the estimate, and then you can put your name here. Activity names and labor category names, let's not get into this at the moment. Let's just use the default activity names and labor category names from SEER. And let's concentrate on these knowledge bases, which is actually a more important thing. SEER is a parametric estimation tool, and SEER is designed to estimate any type of software, okay? In SEER, you can estimate any software from Do178 software that is flying on aircrafts to video games or maybe mobile applications, okay? Banking applications, healthcare, industrial software, any type of software can be estimated in SEER. However, the productivity will vary, okay? You can't compare, for example, Do178 versus web-based report generation, okay? Do178 has more stringent requirements when it comes to testing, quality assurance, documents. So the productivity for different domains and different platforms and different technologies will change. So somehow we need to communicate to SEER what type of software we're estimating, okay? And we do that by selecting these knowledge bases. So we start with platform. The platform knowledge base describes the environment where the software executes, okay? These are the options that SEER offers for platform knowledge bases, okay? And of course, avionics is there, okay? If you are estimating software that is gonna be flying on an aircraft, then it is avionics, the platform that you should use. Other platforms that are supported by SEER include automotive software for vehicles, commercial embedded applications, ground systems, okay? Sometimes we have ground bases, communication systems that are supporting aircrafts. So we have ground systems. We have space systems, industrial, mainframe, unmanned airborne, like UAVs, servers, telecommunications, unmanned space. So all of these platforms are supported by SEER. For a flying software, Do178, you would naturally select avionics, okay? The next knowledge base is the application, okay? So we have communicated to SEER that this thing is gonna be flying on an aircraft, okay? Aircraft or helicopter, whatever, but it's gonna be flying. Then what exactly is it doing, okay? What's the application purpose? What's the mission, okay, objective of this application? We have these options, okay? It may be something that provides controls for certain actuators or surfaces of the aircraft. Maybe something that deals with communication. It might be some sort of data collection or database inside the aircraft. Maybe we're estimating a driver for a piece of hardware, built-in test, diagnostics, general flight systems. This category includes autopilots, navigation systems, and things like that. Maybe it's some sort of graphical user interface like a PFD or MFD, a primary function display, or a main functional display, okay, with lots of graphics. Maybe some sort of process mechanism or process control, radar, user interface, signal processing. It's also very common in aviation. So all of these are types of applications that we can estimate with SEER. So for the purposes of our demonstration, let's imagine that this is a command control, okay? Maybe some electrical control or some control of actuators, surfaces, fuel management, something like that. It's command control. So it's going to be flying. It's going to do command control operations. Now, the next question is, how are we building this? Okay, how are we doing it? There's many ways to generate software. Okay, you can write software from scratch as new development. You could also take a piece of existing software and do modifications. Okay, you may take software that was developed for another aircraft, legacy aircraft, or some different product line of aircrafts, and you can do a rehosting. Okay, rehosting something to be operational in a new aircraft, re-engineering or overhauling of software. So all of these options are available in SEER. And obviously the productivity will be different. Okay, if you decide to do it from scratch, then SEER will estimate full life cycle, going back to all the system requirements, software requirements, design, coding, testing, and integration. Okay, versus, for example, doing a minor rehost. Okay, a minor rehost may be just taking a piece of software that exists, maybe modifying some calibration parameters or some configuration parameters, maybe doing some minor changes to the source code, rerunning a delta or a fraction of the test cases and procedures, and just doing a structural coverage on the modified areas of the source code, and that's it. Okay, so it's less effort if doing a minor rehost, for example, versus doing a new development. Let's use new development for this example. Okay, let's assume that we're building a new system from scratch. The next knowledge base refers to the development methodology. So how are we, what's our life cycle methodology? Are we following traditional waterfall processes and methodologies? Or, for example, are we doing any agile development, which is very common in today's world? Or maybe we're doing a hybrid of waterfall and agile. Do178 and agile sometimes have contradictions with each other. Okay, for example, one of the principles in agile is to minimize documentation, minimize overhead, minimize paperwork and artifacts and documents. Okay, that's something that they try to do that in an agile environment. Focus on the customer, focus on satisfying the customer and producing operational software. However, Do178 requires that you produce a lot of documentation. Do178 asks for specifications, problem reports, review records, configuration management records, quality assurance records, traceability analysis, traceability matrices. So everything has to be very formal. So sometimes organizations end up doing a hybrid between waterfall and agile. Okay, so we have a knowledge base for that. But whatever your life cycle methodology is, you just select it from the list here. Okay, it's just that in today's world, many organizations are either traditional waterfall or agile development. Let us use hybrid agile for this estimate. Okay, The next knowledge base is development standards, okay? Development standards is the reliability and certification standards. And of course, if it's going to be flying, then it needs to comply with Do178, okay? We have the legacy Do178B, and we also have the new Do178, well, not so new, but the current, okay? The current Do178 C, design assurance levels D through A, okay? So whatever your system, whatever the level of design assurance is for your system, you select it from here, okay? So let's imagine this is level A, okay? Something that may result or will result in catastrophic failure to the crew, the aircraft, or the passengers, okay? The next knowledge base is called class, okay? Class custom knowledge base. This knowledge base is optional, and this knowledge base is actually, this category of knowledge bases is actually reserved for you to create your own internal knowledge bases, okay? So let me explain this. The first set of knowledge bases, okay? So these knowledge bases, you know, the platform, application, acquisition method, development method, and development environment, development standards, sorry, we call them industry standards knowledge bases, okay? So these industry standard knowledge bases are maintained by Gallorath, okay? So we deliver these knowledge bases to you as a customer. This is part of the value that you get with a license of SEER. When you pay for a license of SEER, not only you are paying for the estimation engine and the, you know, the commands and the buttons and the graphical user interface and all the nice reports and charts that I show you, you're also paying for the data, okay, the intelligence. At the moment, SEER has close to 20,000 projects in the historical repository. We do statistical analysis, regression analysis, and correlation analysis on that historical data. And that's how we come up with these knowledge bases. So these knowledge bases is basically the intelligence, the data behind the model. When you select these knowledge bases, okay, any given combination of these knowledge bases, you are internally fine-tuning the parameters, productivity factors, drivers, and major assumptions that SEER will put in your estimate. Okay, so these are industry knowledge bases that Gallorath maintains and delivers to you as customers. At least twice a year, we release a new version of SEER, and this new version of SEER comes with updated knowledge bases. Sometimes we add new knowledge bases, sometimes we enhance or modify some of the existing knowledge bases, okay? And sometimes we retire or delete some knowledge bases, but it's very uncommon that we delete or retire a knowledge base because we always like to keep knowledge bases for backwards compatibility, okay? So the first 5 are industry knowledge bases. The last one is reserved for you to create your own knowledge bases. And why would you want to create your own knowledge bases? Well, there are going to be some factors that are specific to your organization. For example, hourly rates, you know, dollars per hour that you pay to your resources. You can put those in SEER using your native currency of your country. Things like experience of your resources, automation tools, okay? Maybe you're using something like, you know, something like VectorCast for automation of unit testing and structural coverage. Maybe you're using something like Skate or MATLAB Simulink for model-based development. So things like that are internal to your organization, and, you know, things that you think can influence the productivity of your projects, you can save them as a class custom knowledge base. Using a class knowledge base is optional, and in fact, I'm going to leave it blank for this estimate, but keep in mind that on top of all the industry data that comes with SEER, you can put your own calibration, okay? On top of the industry calibration, you can put your own internal calibration. I'm going to leave it blank for this. All right, so we have is enter a description for our estimate. We have selected the knowledge bases. So now SEER knows that we're doing aviation from scratch, design assurance level A. All right, so SEER knows the flavor. Let's call it the flavor of software. So we're doing embedded, mission critical flight software. We're not doing video games. We're not doing mobile applications. So SEER knows the details already. All right, let's just now go ahead and click OK. And let's see what's next, okay? Okay, so we now have an estimate, okay? At least, well, it's not an estimate because there's nothing being estimated here, but at least we have a shell. We have a placeholder for our estimate. Okay, so from here, the process now is very simple. It's basically three steps, okay? Three steps that we need to follow, okay? Step number one is word breakdown structure, okay? Right here, we need to create at least one word breakdown structure element, okay? In our project. Step number two is parameters. We need to enter some basic information about sizing, okay? Step number two is more in particular size, okay? We need to quantify the amount of software that needs to be produced. Okay, so step number two, more specifically, is yes, it's parameters, but it's sizing parameters. And then step number three is additional parameters that we may decide to adjust. Okay, so additional parameters such as capabilities and experience, automation tools, and other assumptions. Okay, that's the, I call it the three-step estimation process in SEER. So let's demonstrate that. So to create an element in the word breakdown structure, we're going to click on this button that says Insert Element. And now SEER opens a window for us to create a new element, okay? So this element represents something in your system, in your software. It could be the entire software. It could be a sub-application or subcomponent, a module. The word breakdown structure in SEER is flexible. As the estimator, you decide if you create a very high-level WBS structure, like just one element representing everything, or if you want to get to a level of granularity, something like the estimate that I showed you before, you decide the level of granularity that you go with this, okay? So let's say we're creating some, let's say, maybe a navigation software, okay? Notice that SEER is asking us for knowledge bases again. Okay, we already selected these knowledge bases when we created the project. Okay, but now SEER wants to know if for this particular element, okay, for this navigation software, if we want to update or refine any of these knowledge bases. So you have the option to refine any of these. For example, if this navigation software is not new development, I can change the knowledge base, okay? So every or each WBS element that we create in our estimate has its own knowledge bases and its own calibration. And this is step number one, okay? Creating an element and selecting the knowledge bases. So let's assume that the same knowledge bases are applicable to this navigation software. And let's just say this is new development. Sorry, this is supposed to be a parenthesis. Okay, let's just say this is some new software that needs to be produced for this navigation software. Click OK. So that's step number one. Step number two is sizing. Okay, we need to communicate to SEER how big is this new development for this navigation software. When it comes to sizing, SEER offers all the sizing approaches that are available nowadays. Okay, so SEER has, for example, lines of code. If you want to size your software using lines of code, we have parameters for that. If you want to use function points, okay, SEER has function points as an input. If you're not familiar with function points, basically function points are an industry standard for functional sizing, okay? It's a way of measuring the size, the functional size of a software application from the specifications or from the requirements. So SEER can support function points for sizing. In addition to function points, we support any of these other things. We can do other flavors of function points, such as cosmic, quick and early function points. We can do things like teacher sizing, okay, functional teacher sizes, story points, which are very popular in Agile. We can do use cases. And basically, we have all the different sizing mechanisms that are available nowadays, all right? You could also create your own sizing metrics. For example, as you can see, I have here some Lockheed Martin size metrics. This is something special that Lockheed Martin uses, for example, to estimate their projects, okay? So I cannot get into the details of this, of course, because this is proprietary, but you can create your own sizing approaches in SEER. If you want to count the number of functions, classes, or the number of branches, you can calibrate a sizing metric in SEER for that. Lines of code and function points are the most popular sizing approaches that anyone uses. All of our aviation customers, they either use lines of code or function points. So in SEER, we need to enter size, at least some notional size, so that SEER knows the volume of software that we're estimating. Imagine, for example, for a second, let's imagine that we are, let's say, builders, okay? Instead of doing software for living, let's say we build houses for living, okay? So we build houses. When we want to estimate the cost and the effort of a new house, what's the number one thing you want to know? Okay. How beautiful is the house? Probably not. That's, the materials, the quality. Probably those things are important, but the number one parameter is square meters of construction or square feet of construction. We need to know how big the house is. That's probably the first thing a construction contractor is going to ask you. Give me your square meters. If you were building highways, what's the first thing? Well, kilometers, how long of a highway and how many lanes, right? So sizing is the most important thing. And software is not the exception. So we also need to quantify the amount of software that needs to be produced. For the purposes of this demonstration, I am going to use lines of code, which is still one of the most popular sizing approaches. If you can estimate the amount of slug that needs to be produced, all we need to do is enter that information here. So let's imagine that we come up by analyzing the system level requirements and the high level requirements and the complexity and all that. We estimate that we may need to develop between 5,000, likely 8,000, and worst case 12,000. Notice here, this is a very important concept in SEER, the concept of probabilistic distributions and least likely and most. When you pass information to SEER, you're going to be passing that information as a range, okay? Not as an absolute value, but as a range. And this is for you to communicate risk and uncertainty to SEER. What uncertainty? Well, the uncertainty with the amount of code that needs to be produced. For example, I think it's going to be 8,000 slug, but it could be as high as 12,000 lines of code, or it could be as small or as low as 5,000 lines of code. Okay, I'm communicating uncertainty and risk. The risk that it goes higher than 8,000, or the opportunity, okay, that it goes lower than 8,000. Okay, this is called uncertainty ranges. And that's how you pass information to SEER. So we enter the size, click OK. As soon as we enter the size, SEER computes an estimate, okay? Notice that right after we enter the lines of code or the function points or whatever the size is, SEER computes an estimate. SEER is telling us right now that something this big for Do178, design assurance level A, basically all of these knowledge bases, is going to take 23 months. It's going to take 12,000 hours, and it's going to cost us $2.4 million. Okay, so SEER produces a preliminary estimate based on this. And going back to the three-step process, we have right here, again, step number 1, create a word breakdown structure element. Step number 2, enter the size. And then step number 3 is fine-tuning environmental parameters. So let's talk about that. Let's imagine for a second that after we enter the size, we get a preliminary estimate, but we think it's too high or too low. Let's say we're not satisfied with this estimate. We think that some things may need to be adjusted for these numbers to be more in line. So I'm going to set a reference here so that you can see how the parameters work. Okay, so we're now in step number 3, which is fine-tuning of parameters. Okay, SEER has plenty of parameters. Look at this. SEER has parameters to describe your personal capabilities and experience. It has parameters to describe your development support environment, your product requirements, reusability, complexity, target environment. So many parameters are there, but look at something. All of these parameters are already preset, pre-initialized to values. Okay, so SEER is already telling me what those parameters should be. Okay, how does SEER know what the values for these parameters should be? Well, remember I told you that we have close to 20,000 projects, historical projects in our repository. So basically, when we select a certain combination of knowledge bases, okay, when we tell SEER that this is aviation, command control, new development, hybrid agile, Do178 DAL-A, SEER goes to the repository of projects and it says, okay, let's look at similar projects and let's see what the typical analyst capabilities, programming language experience, automation tools, multiple site development, testing level, quality assurance level. So SEER goes and looks at the default values, nominal values for the parameters, and it gives you those values by default. Okay. Again, this is the intelligence. This is the data. This is part of the value that you get with a license of SEER. If you don't have a clue of what's your level of automation or experience of the resources or level of testing, quality assurance, we have an answer for you based on our historical collection of data. We're looking at similar avionics DAL-A projects, and we know what the typical parameters are. Okay. As an estimator, you may choose to override or refine any of these parameters. For example, imagine a situation where this project has participation from multiple geographical locations. So maybe some development in the US or Japan, and maybe some testing or quality assurance activities done in India. Okay, so we all know that there are inefficiencies due to communication. Sometimes there are inefficiencies due to different time zones, language differences, and things like that. So SEER has a parameter for that. It's called multiple site development. Okay, so multiple site development. As you can see, when you click on the parameters, SEER shows a description of the parameter and description of the different ratings for the parameter. So for example, nominal, which is the current value for this parameter, means the team is collocated. Okay, if that's not the case, we can increase this. Let's increase it to high. High means a team that is distributed across 2 geographical locations. Let's say this is Japan and US. Okay, so we have operations or contribution from resources in United States and Japan. Click OK on this parameter. We are now introducing an assumption. Okay, this parameter that we changed, as you can see, is now highlighted in a darker font. It's highlighted in bold. It has a justification that we enter here, and it introduces a change in the estimate. So because we have participation from multiple geographical locations, SEER is giving us an extra 8% of budget. So that extra 8% represents an additional 1,032 hours and also an additional 0.64 months of duration, okay? An extra $200,000 in this case. This is an assumption that I am making on top of the industry standard parameters, okay? And this, ladies and gentlemen, is basically step number 3. Step number 3 is adjusting any of these environmental parameters to reflect things that are unique, okay? Any risks that you may have, any assumptions that need to be factored into the estimate, okay? Step number 3 is optional. Remember, it is optional because SEER is already giving us default values for these parameters that are typical of the project that we're trying to estimate, okay? So just like I updated or refined my estimate for multiple site development, I could have done an assumption about, for example, stability of the requirements. Imagine a situation where the system level requirements are still changing. So we start creating the HLRs and the LLRs and the source code and all that, and all of a sudden, boom, there's a change in system requirements, and then that forces us to update the SRD, update the SDD, update the source code, update the test cases and procedures, rerun the test cases and procedures, structural coverage, etc., etc. So that's called requirements volatility. We have a parameter for that. For example, we can make an assumption that we might be having some occasional changes, maybe some prototyping, okay? We can say something like system level requirements still on their evolution, all right? Just factor an assumption, the risk that we may, suffer from changes in system requirements. Click OK, and look at this. More contingency gets added into our estimate. We're now looking at an 18% contingency. So the original estimate was 12,000 hours. We're now looking at 14,000 hours. That's an 18% increase based on these 2 assumptions that we made. So SEER has parameters to make assumptions from any perspective, okay? Anything that can potentially impact a software development productivity, SEER has a parameter for that. So this is step number 3. And that's basically the process that you follow. So it is as simple as that. We create an element in the work breakdown structure, okay? Select the knowledge bases for that element. We then enter the sizing information, which we did here as lines of code. Step number 2, okay? And then finally, we refine environmental parameters as needed. And that's the super simple 3-step estimation process that you follow in SEER. If your project involves several or more work breakdown structure elements, you basically repeat the 3-step process for each element, okay? So to get to something like this, get to this one, for example, I followed the same process for this element and this element. I created the element, selected the knowledge bases, entered the size, and fine-tune any parameters. And I followed the same approach for each of these elements. So after this, it becomes just a repetitive 3-step estimation process that you would follow in SEER, okay? Now, imagine we are satisfied with this estimate. Let's imagine that we have fine-tuned the sizing and the parameters to the best of our knowledge, and we're happy with the estimate. So let's go ahead and clear the reference right here. Let's save the estimate. I'm just going to save this in my desktop. Next thing you may want to do is benchmarking, okay? How do we know if an estimate is realistic? How do we know if $2.8 million, 14,000 hours is, by the way, before I talk about benchmarking, let me quickly show you the economic factors, okay? Because this is something that may be useful for you in other countries other than the United States. Internally, SEER computes effort hours, okay? That's what the estimation engine in SEER computes, all right? It is hours. Those hours are then allocated to the resources, okay? So SEER has resources such as project manager, business analysts, designers, programmers, testers, configuration management, and quality control. Each of these resources has an hourly rate or some sort of rate. Those rates are defined on this economic factors area in this tab. So here, you specify what's the monthly rate of your project management role, the monthly rate of your an analyst, the people writing high-level requirements and low-level requirements, the monthly rate of your programmers. So these rates that you see here are based on US. If you're doing estimates in a different country, I recommend that you replace this with whatever your currency is and the cost of your resources is, so that SEER can correctly estimate the cost of the project. Okay. All right, so back to the estimate. All right, let's talk about benchmarking. Okay, how do we validate that the estimate is feasible, achievable, that it complies, or that at least it shows a similar productivity to what other organizations have achieved? SEER gives us the option to benchmark the estimate, okay? So if I click on that metrics button, I can see the projects that are in the historical repository. This includes projects from all industries, all platforms, all programming languages. We want to compare this, or we want to benchmark our estimate against projects that are similar to our project, okay? We don't want to benchmark against banking, healthcare, video games, mobile applications. We want to see what other aviation companies, Do178, DAL-A, for example, we want to show what those projects are, so that we can do a more, representative, okay, benchmark. So what I'm going to do now is I'm going to click filter and retrieve, and I'm going to ask SEER to give me, say, for example, only embedded, okay, embedded applications, and click apply. Okay, so this is how our estimate right here, this is our estimate represented by this blue triangle. And by the way, this range represents, this is the probabilistic distribution. Remember, I told you, SEER produces a probabilistic distribution of the estimate. If I go back to our estimate, even though we're looking at 14,000 hours, that's just 1 point in the probabilistic distribution of the estimate. In reality, SEER produces a range, and it tells us that our project can be anywhere from 3,476 hours all the way up to 65,000 hours. Obviously, the 1% and 99% probability are extreme situations, but we know our estimate is somewhere in between this range. SEER reports the middle point of the probabilistic distribution, and in this case, it happens to be 14,397. This probabilistic distribution, by the way, this is based on the least likely and most ranges. So the uncertainty that you specified in this, for example, the uncertainty that we have with the lines of code and all of these parameters, SEER converts that into contingency in your estimate. So back to the benchmark. This range here represents the probabilistic distribution. And right now we're looking at the 14,000 hours. This benchmark is size versus effort, okay? Obviously, larger, higher lines of code or larger applications tend to require higher effort. So that's what you see. This is a trend line going up as you move to the right. What this is telling us is that our estimate is close, is similar to what other mission critical embedded applications have done in the past, okay? This middle line here represents the trend line of the industry. This one here is +1 standard deviation, and the other one down here is -1 standard deviation. So this is a range, okay, from the trend line, 1 standard deviation, -1 standard deviation. So as long as our estimate is somewhere in that vicinity, in that ballpark of +-1 standard deviation, we can have, at least we can have some confirmation or some benchmark or some sanity check that the estimate is realistic. Because other organizations that have done aviation, Do178, have achieved some, similar result or similar productivity. If we were seeing, for example, our blue triangle, let's say up here, if we were seeing our estimate, say, up here, then that'll be an indication that the project is too expensive because something this big could be costing this much. But according to the industry trend line, it should be costing less money, okay? So you always want to see your estimate hopefully close to the trend line, okay? It doesn't have to be exactly on the trend line because we could have made assumptions, we could have made parameter adjustments that are deviating us either up or down from the trend line. But in summary, this is a good sanity check, confirmation that the estimate is realistic according to industry data. The beauty of this capability within SEER is that not only you can benchmark against the industry data that comes with SEER, if your organization has historical projects that you have done or your suppliers have done for you before, you can load historical projects in the database of SEER. So you can do the same benchmarking analysis, but now you could do it against your own data. Let me show how that works. Okay, so I can tell SEER, for example, rather than benchmarking against industry data, let's benchmark against our own data. So let's imagine we are Acme and we have some historical data. So filter and apply, okay? So as you can see, this is a similar benchmarking exercise, but this is using your own historical data. So SEER offers the capability to load historical projects, completed projects in the historical database and benchmark your estimates against that. So you can see that your estimate is realistic when you compare it to the rest of the industry, and also when you compare it with similar achievements, similar projects that your organization has done in the past. Okay? So ladies and gentlemen, this is all the information that I wanted to convey and communicate. It's my pleasure. So feel free to share any questions you may have on this. And again, this was a demonstration of SEER for software specific to embedded aviation Do178 projects. Thank you very much for your time.